So in the last video, we talked about what percent yield is. We talked about the equation to calculate percent yield. We talked about why actual yield often doesn't reach 100% and why we can't make the amount that we should be able to make in an actual lab. And we did this one question where we looked at the reaction of calcium carbonate with hydrogen chloride to make calcium chloride and carbon dioxide and water. And part A of this question required us to calculate the amount of product that could be formed when given the amount of reactants. So in part A, we were given 15.7 grams of calcium carbonate, 10 grams of hydrogen chloride, and we were asked how much of this product, carbon dioxide, could be formed with 81.5% yield. So we determined the limiting reagents. We used it along with the mole ratio to determine the moles of carbon dioxide that could be formed, and then we determined the mass of carbon dioxide that could be formed. Again, all this is knowing that the yield is 81%. So that number that they calculated is theoretical yield. We then realized that only 81.5% of that amount could be formed, and then we use the equation to calculate that amount. So all of that was in the last video in percent yield part 1. This video is about part B. What mass of each reactant is needed to produce 35.0 grams of calcium chloride? So again, I'm going to refer to part A. Part A, we did this. And we realized that this was the limiting. And our question mark was right here. This was part A. Part B is now talking about the opposite. So I'll copy down the equation again. And instead of giving you an amount of reactant and asking you to calculate product, now we want to know this. We're saying that we want to make 35.0 grams of calcium chloride. Calcium chloride. 35.0 grams of it. And again, knowing that the yield is 81.5%, how much of each reactant do we need? So now we are actually going the opposite direction. Now just keep that in mind as we are doing this question. So stoichiometry can go back and forth. Stoichiometry can be used to calculate the amount of product that's being formed. Stoichiometry can also be used to calculate the amount of reactant that's required if you know how much of the products you want to make. So here is our equation again. So how is this question different from anything we have done before? I mean, we still know that we're going this way. So that gives us this reactant, or the mass of this reactant. This gives us the mass of this other reactant. But the difference is when they tell you how much of the reactant they want to make, what they mean is this is how much reactant they need to make in an actual lab. So this is our actual yield. Why is this important? It's because our percent yield is 81%. 81.5% from question A. So if you want to make 35 grams of it, in your calculations, you should account for that, the fact that some of this reaction is going to go to waste. A lot of this reaction is not going to, or how much of this? 18.5% of this reaction is not going to make this amount of product. So if you want to make 35.0 grams of it, you kind of need to plan on making more, just so that if something in the reaction goes wrong, you still end up having 35.0 grams. So what we need to calculate and use in this question is the theoretical yield. It's kind of like you making a meal, or kind of like you making s'mores. If nothing goes wrong in the reaction of making s'mores, and I want to say I need to make 4 s'mores, you can tell me how much of each ingredient I need. So if I want to make 4 s'mores, for example, you would tell me that to make 4 s'mores, I need 4 marshmallows, I need 40 chocolate chips, and I need 8 wafers. But knowing that some of this reaction will fail, and knowing that in here around 20% of the reaction fails, I just use the word fail very loosely, again for all the reasons that we mentioned in part 1, if you want to make 4 s'mores, if you want to end up with 4 s'mores at the end, you have to maybe make a little bit more, just so that in the process of making s'mores, let's say you burned a marshmallow, or you broke a wafer, or some of the chocolate chips fell on the floor, you don't end up with, like only 2 s'mores per se. Okay? If you want to make 4 s'mores, you should buy extra material. Right? So you should maybe plan on making 6 s'mores, so that even if something doesn't turn out, you need to buy enough materials to make 6 s'mores. Okay, so that's called theoretical yield. So applying it to this, again, we can use the equation. So 0.815 equals actual over theoretical. So T is equal to 35.0 divided by 0.815. So a theoretical yield is 42, and I'm going to leave a bunch of decimal places just because this is only our first step. So this is what we're saying. We're saying that we need to make this much in the lab, but knowing that some of the reaction fails, we cannot just have enough material to make 35 grams. We need to we need to buy or have enough reactants to make 42 grams, so that if part of the reaction fails and we don't end up with 42 grams, that's okay. Hopefully we'll still end up with 35 grams, knowing that some of the reaction fails. So we're going to actually not use this number in the reaction, or in our calculation for how much reactants we need to put in or purchase or whatever. We're actually going to use 42.945 grams and go on and calculate the amount of reactants that's needed to make this amount. So now I've run out of space. That means I have to write the equation again so I have more room to do the math. So we just calculated that we need to plan on making 42.945 grams of this, and now we're looking at how much of each reactant we need to make that amount. So we can divide this by the molar mass of calcium chloride, which is 110.984 grams per mole, and so that is equivalent to 0.3869 moles. If this is the amount we need to make, then we should have 0.774 moles of hydrogen chloride. I'll make this mole ratio more clear. This mole ratio is times 2/1. And then now we can multiply by, actually, you know what, let's go and calculate what this amount should be for calcium carbonate. Again, I have written the wrong formula, CaCO3. The mole ratio for this is 1:1. So this is 0.3869 moles. So now that we have the moles, we can calculate the mass of each reactant we need. So mass of HCl is equal to the moles of HCl, 0.774, times moles times 36.453 grams per mole. That is equal to 28.2 grams. And then the mass of calcium carbonate is equal to 0.3869 moles times 100.078 grams per mole. Should be around 38. 38.7 grams. So therefore 28.2 grams of HCl and 38.7 grams of calcium carbonate are required to make 35.0 grams of calcium chloride. So again, remember that these amounts that you put in your reaction, according to a calculation, yes, it should make 42 grams, 42.9 grams. But again, based on yield, you cannot make that much. And in reality, even though you fully plan on making and you put in enough reactants and everything to make this many grams of product, because of yield, what ends up happening is you're only able to make 35 grams. So what do we do in this question? We wrote the balanced chemical formula. We then figured out that the number they gave us that they need to make in the lab is the actual yield. We then use the percent yield formula to calculate the theoretical yield, and then we put that into our stoichiometric calculations, and from then on we determine the amount of moles required to make that many grams of calcium chloride. But knowing that the yield is 81.5%, when you plan on making this much, the reality is you only end up with 35.0 grams.